Welcome to This Explainer. Today, we're asking a pretty massive question. Do we actually control our technology? Or is it, controlling us? It's literally the core of our digital existence right now.
Let's just jump right in. We're currently drowning in this massive digital divide. On one hand, we've got probabilistic AI, suffering from what's called fax machine decay. And on the other, bloated, totally opaque corporate updates that silently strip away your agency. I mean, think about it. When was the last time you truly understood every single process running under the hood of your machine?
So here's our roadmap from high-level philosophy all the way down to the bare metal. We'll cover the illusion of control, the sovereign Lisp REPL, permacomputing, the 100 Rabbits Collective, bridging text to reality, and finally, ultimate control.
Starting things off with Section 1, the illusion of control, bloat, and black boxes.
Right now, we're basically trapped in this ecosystem of massive corporate bloat. Like, we just casually accept downloading a 10-gigabyte developer environment, like Xcode, just to write some basic code. Crazy, right? Meanwhile, modern AI models act kind of like lossy zip files. They gorge on all this data but spit out unpredictable, probabilistic guesses. They're just generating the next most probable word, not recalling exact facts. And when they inevitably mess up, we are left in these moral crumple zones. The machine's complexity totally obscures the responsibility, leaving humans to just absorb the damage. We're settling for this mere facsimile of intelligence instead of demanding exact deterministic fidelity.
Which brings us to Section 2, the sovereign Lisp REPL, and how we start reclaiming the state.
To actually reclaim that control, we have to look at the Lisp REPL. It acts as this incredible self-reflective reasoning loop. REPL literally stands for read, eval, print loop. And when you access it through a powerful text editor like Emacs, it completely rewires your relationship with the computer. Instead of that rigid, old-school cycle of writing code, compiling it, and running it totally separately, the REPL reads your expression, evaluates it according to Lisp's rules, prints the result, and loops right back. It's maintaining a continuous live state.
And that contrast is the absolute key here. You are not stuck compiling some dead artifact. With standard compiled software, execution is walled off. To change something, you literally have to kill the process, rebuild the whole thing, and start over. But a live Lisp REPL, it's a living, breathing connection to the software. You can interactively inspect, define, and redefine your functions right at runtime without ever terminating the parent process. Every single decision traces directly back to you, creating this unbroken chain of authorship and control.
Moving on to Section 3, permacomputing and digital resilience.
This deep desire for deterministic control actually scales out into a whole lifestyle, one that radically rejects the tech industry's obsession with planned obsolescence and those massive energy-hungry cloud architectures. It takes direct inspiration from permaculture, the practice of creating sustainable ecological systems. Permacomputing asks a really provocative question. Can we rethink our tech to actually contribute to the biosphere instead of just draining it? It's all about digital sustainability, demanding we maximize our hardware lifespans and learn to do so much more with way less.
We can break this down into 3 methodologies, showing it's not just some abstract theory. It's a real, practical framework for digital survival. First, there's frugal computing, which strictly limits resource use to the absolute minimum required. Then, salvage computing. This is deliberately using hardware that's already been discarded, literal e-waste. And finally, collapse computing. This actually prepares for a future where industrial networks fail, making sure our systems can run purely on what survives. It's all about practicing planned longevity to break that vicious cycle of planned obsolescence.
Next up, Section 4, the 100 Rabbits Collective, and what it really means to compute off-grid.
To show you what this looks like in practice, look no further than the 100 Rabbits Collective. Formed by Divine Lou Lindvega and Rec Bell, they literally live in the middle of the Pacific Ocean aboard a sailboat. They operate entirely off the grid, and they are successfully building incredible software tools completely disconnected from modern corporate infrastructure. Their entire studio runs within the strict physical limits of small solar panels, battery banks, and totally secondhand hardware. They are the living, breathing embodiment of permacomputing.
And here is how they brilliantly pull it off. Remember that bloated 10-gigabyte Xcode download we talked about earlier? To avoid that, they built their own radically minimal computing stack called Euxin and the Varvara system specification. Euxin is just a tiny 256 instruction virtual machine. Because it's so small, they can run full development environments, writing software, rendering vector graphics, even sequencing music with tools like Orca on literal e-waste.
We're talking about running a full operating environment on an old Nintendo DS, a Game Boy Advance, or an ESP32 microcontroller. They stripped away all the modern bloat to find absolute hardware longevity.
Section 5, Bridging Text to Reality, or the Descent to the Metal. So, how do we make this happen? Well, text serves as our universal deterministic interface. Think about it. Human thought is fuzzy, it's creative and associative, but a computer's arithmetic logic unit, the ALU, is incredibly rigid, discrete, and purely mathematical. Text acts as this semiotic bridge. It's the secure translation layer that safely compiles our messy human imagination into exact, verifiable hardware execution, completely bypassing those bloated, abstracted graphical user interfaces. This pipeline right here shows that exact ascent down the abstraction ladder. We start with pure human intent. We type it into a text buffer, like Emacs. Then, we send it over a raw serial connection straight to a microcontroller running ULisp, and boom, that text immediately triggers a physical change, like toggling an LED on a GPIO pin. We're deliberately trading away the flexible, probabilistic bloat of modern software and stripping it down step by step until our intent hits unyielding physical ALU fidelity.
Tools like ULisp make this transition completely seamless. ULisp is a highly optimized Lisp interpreter designed specifically for microcontrollers like an Arduino. It can run on severely constrained devices with as little as 2 kilobytes of RAM. 2 kilobytes! What's really amazing is how it maps Lisp keywords directly to the physical addresses on the silicon itself. So you can write to port B using bitwise functions right in your REPL and instantly flash a physical LED. You're using plain text to prove your absolute authorship over the machine's physical state.
By doing this, you completely bypass the standard static programming lifecycle. Normally, with a microcontroller, you're writing C++ code, waiting on a heavy compilation process, and suffering through those slow upload cycles. You make a mistake, you start all over. But with ULisp, zero compilation needed. Your Emacs text buffer transforms into a live, interactive physical control panel. You evaluate a line of text, and the hardware responds instantly. It's a total game changer.
This journey straight to the bare metal reaches an absolute peak with devices like the LilyGo T-Deck. Check this out. It's an entirely self-contained handheld Lisp machine that you can carry anywhere in your pocket. It's got a color display, a 35-key keyboard, and it runs independently on an ESP32 chip. It perfectly embodies that sovereign, off-grid computing philosophy we've been talking about. It's a tiny, resilient tool granting you direct, unmediated control over your digital environment, with no reliance on massive servers or constant, forced updates.
Finally, Section 6, Ultimate Control, the steward of the machine.
The ultimate takeaway of this explainer is that you actually have to choose to be the steward of your hardware. By understanding the sovereign REPL, embracing the harsh but necessary lessons of permacomputing, and tracing your text all the way down to the physical silicon, you reclaim your agency. You actively practice planned longevity instead of just blindly accepting planned obsolescence.
I want to leave you with a final provocative thought about your own digital sovereignty. In a world that is increasingly dominated by opaque, lossy, statistical engines and massive corporate bloat, what are you going to choose? Are you going to let the probabilistic noise and 10 gigabyte forced updates run your life, or will you use the universal interface of text to claim your digital sovereignty? Think about how you can take back control of the computers in your life right now. Thanks for joining me on this explainer, and keep exploring.